So in order to do this project, we will need a wood table, a battery of 9 volts, a battery connector, a 2N2222 transistor, a resistance of 22 kilo ohms, a switch, a cylinder of a non-conductive material, a copper wire of 0.5 centimeters of diameter, a cable, tape, a gas light bulb, tin, and a solder gun. First of all, we have to wind the copper coil to the tube, and here it is how it's done. Wait. This isn't supposed to be an 8-minute winding video, so why don't we add a bit of speed?
Two hours later.
And here it is, the most important piece for this project, the bobbin. After finishing the bobbin, we now are gluing the switch to the wooden table. We tape the transistor to the wooden table. Later, as you can see in the video, we're sticking the bobbin in the wooden plate and putting it into the correct position. Later on, we're peeling both ends of the coil. Meanwhile, you can listen to this fantastic piece. Now we take the wire and we round it around the bobbin just one time. Due to the current passing across the wire, an induced current will be created across the bobbin, and this is going to create a magnetic field that later we are going to change by changing the angle of the light bulb, and this later is going to light the bulb. At this moment, we are taking the 22 resistance and we solder it to the middle leg of the transistor, of course using the solder gun. Going on, we take the lower end of the bobbin and we solder it to the middle leg of the transistor. Yeah, you may see a small difference in the length of the end. That is because we realized it wasn't long enough, so we unwind it. The following procedures implicate the solder of the wire rounding the bobbin. The left end of the wire will be connected to the left leg of the transistor, and the right end is going to be soldered to another wire, which is going to be soldered to the resistance. We are also taking another wire and we solder it from the switch to the resistance. To conclude, we solder the red wire of the battery connector to the switch and the black wire to the left leg of the transistor. And that's it, we connect the 9-volt battery and stick it to the wooden plate. So now let's start with the explanation. In a Tesla coil, the secondary coil, the bobbin in our case, will be the conductor, and the varying magnetic field will be produced by a primary coil, the wire around the bobbin, by passing an accelerating current through the primary coil. The main component in this circuit is the secondary coil, which is made by winding a magnetic wire enamelled. That's why we peel both ends of the secondary coil around a non-conductive object, in our case the cardboard cylinder. A high current is used to supply current through the primary coil, and the whole setup is powered by a 9-volt battery. The positive end of the battery reaches the collector of transistor through the primary coil, and the emitter is grounded. This means that whenever the transistor conducts, current is flown through the primary coil. Since the number of turns in the secondary coil is very large compared with the primary coil, this voltage will be a very high voltage, so this coil will have a very strong electric flux around it, that is powerful enough to glow a gas bulb, by ionizing the gases at low pressure, with the magnetic field variation. This whole project was done by Christopher Carmona, Adrián Caballero, Gorka Larrauri, and Jon Zorrigueta.